Well, hello everybody. We are today at the hacker space in The Hague, Revspace, and this here is the other big 2018 project that I alluded to way back in the beginning of 2018. And this is chemistry. I really like chemistry. I'm not a chemist by trade, or I don't even have any formal education, like aside from my secondary education. But I really like chemistry. I like trying to synthesize stuff and trying to, basically exploring the science of all kinds of cool chemistry, including stuff that is very relevant to power electronics, like getting to the bottom of how ferrites work and lithium-ion batteries and that kind of stuff. Now, of course, to do chemistry safely, well, if you know what you're doing, you can do it anywhere, but really what you want to have is something like this. This is a fume hood. It is a cabinet, a closed cabinet with a polycarbonate window and a kind of inert fiberglass, in this case, sash around it. So aside from just being kind of a safe box to work in, it's got an extraction fan and some drawers and a cabinet and some more of these yellow drawers here. These yellow cabinets to the side here also contain all kinds of cool chemistry stuff. Now, I built this myself, and this project actually started almost half a year ago in October of 2017. And I kind of started documenting the process. Here you can see me doing stuff on the cabinet. But it is a very long and involved process. There's about 60 to 80 man hours in this cabinet. It was a little bit too much of a hassle to also do the filming as well as the actual construction. And this is not in the least because the fume hood has a couple of annoying issues. Because of budget constraints, I decided to make it out of wood. And this went very well at first, but of course, wood, it works when it gets moist and temperatures change. And the entire fume hood ended up being a little bit crooked. It warped, and we had to reinforce it. So as you can see, there's an H-frame. So there's like a leg there, here. There's a thick bar, and then there's another leg. And there's even a little bit going up there. What I'm pointing at is a steel frame on the front of the fume hood that is keeping everything straight. And that's also a convenient mounting point for the window frame and that kind of stuff. And not only that, there were a bunch of stops and starts in this project. Not in the least in the later stages. It was kind of a hassle to get the glassware that we wanted and to get the extraction filter we wanted. So those projects kind of ended up being hack jobs. There was really no other way around it. But all of that is fine, honestly. It doesn't really matter for the functionality of a fume hood. And I like to run through what a fume hood should actually be and what kind of features it has that enhance the safety of doing chemical experiments. So first of all, of course, it has a window, and the window is polycarbonate. This is a polymer that is relatively thermally stable, but most importantly, it is shatterproof. So if we're doing an experiment at pressure and something decides to explode, we don't get shards of glass embedded in our bodies. They will instead be embedded in the polycarbonate window, or most likely they will just bounce off. The window is a slide window that closes down. This is pretty important. You will see that almost all fume hoods have either this or sprung sideways doors. And this is so that the default passive position is down. So the entire fume hood gets closed automatically if anything happens. It's not like the door suddenly can fall out or slowly creep open. The entire inside of the fume hood is lined in various inert materials. So the sides, the back, and the top of the fume hood are all clad in glass fiber. This is like the glass in most chemistry stuff. It is just glass. It is pretty much inert to everything except for hydrofluoric acid. Likewise, the bottom is actually a glass surface. It's just a like window glass, a single pane. So the fume hood has a lip, and this lip enables any big spill, in fact spills of up to 20 liters of fluid, to be contained within the fume hood. It is entirely lined with glass as well, so this is actually a glass surface. So whatever you spill, it will be contained entirely within this volume, as long as, of course, the fume hood is relatively level. And this is especially relevant if you just walk away and suddenly the hose of your condenser pops off and starts spilling just tap water everywhere. It would be very annoying to have to clean that from the floor, especially when it mixes with other chemicals, maybe dry chemicals you have lying around. Of course, there is a need for electricity inside the fume hood, and most notably, you need a hot plate stirrer for most experiments. So there is there's standard outlet up to 16 amps, and of course there's a light switch, very handy, and a switch to turn on the extraction fan. The entire back, sides, and the top of the fume hood are pockmarked by these little thingies here. These are bolts, M10 bolts, that mate into steel rods that are mounted inside the balls. And well, you can tell what we use them for. You can get out one of these plugs and put in these rods. These are just regular 10 millimeter stainless steel rods that I have threaded on the ends. And you can hang your chemistry glasswork off of that. Now, in regular chemistry setups, you use lamp stands. So these are like cast iron feet, painted, of course, or enameled, that you put these rods into that stand from the floor. I mean, this is fine. Obviously, the world has used these for dozens of years, but they do tend to become very dirty with spills and that kind of stuff over time. And it's also just like you have to put it somewhere, so you are removing the space for putting, for instance, these hot plate stirrers, which seem to be getting bigger every year. So in order to just save space and save cleanup time, keep this nice work surface, I decided to put the lattice work in the walls and the ceiling. Additionally, there are 6 hose fittings here, one for cooling water in and one for cooling water out. Then there is 2 for pressurized air and vacuum, and there is one for active gas, so like natural gas or butane for a Bunsen burner, and one for passive gas, something like argon if you need an inert atmosphere. And of course, these fittings are mounted like in a watertight fashion on the inside, and then they go to these hose connectors, various different hose connectors on the outside. So these are pressure connectors. There are some regular water hose connectors, like outside hose connectors on the outside. And in the middle, there are regular barbed connectors. Most of the glassware is stored in these drawers. We have amassed a decent amount of like secondhand glassware in the past years, or actually like one person on the space has amassed this. But a lot of stuff was missing, so we decided to just buy a whole bunch of new stuff just, I think, a month ago. And we have that all here now. Pretty much everything you need for simple synthesis is here. Additionally, we have these yellow cabinets that we use for the chemical storage. We have an online system. This is actually a printout of part of that, where we keep tabs on exactly how much we have of everything, and we keep it all sorted in various cabinets. They're lockable, but honestly, these locks are very easy to defeat. So this is just like a warning: don't just grab these and eat them or something. The fume hood extraction system is actually pretty complicated. So here we see the exit from the fume hood, just about. The hose begins here, and then it goes to this first white box with the hinges. And this box is the filter box, actually. So you might be able to tell this hose goes in a little bit more towards you than this hose comes out. There's a big transverse activated carbon filter there that neutralizes pretty much everything you throw at it. We have tested it. It is not quite strong enough to get rid of the nastiest chemicals and stuff like concentrated ammonia. These things are very easy to smell and very hard to get out like fully, but it's good enough. Now this box goes to the actual extraction fan. So extraction fan is this here. It's just a regular fan. It's a synchronous motor fan. It's PVC and it is closed. The motor section is completely closed to the fan section. This is important. If there are any flammable gases, you need to have something that is what's called intrinsically safe. The same goes, by the way, for all the material choices. These hoses, they can absolutely not be something like aluminum or steel. They have to be PVC or some other relatively inert material. PVC is like the best material ever. These boxes, they're just wood with PVC lining, and that is apparently good enough to resist most chemical attack. It's pretty awesome. And then right here is the exhaust of the extraction fan, and you can see it is another box painted red. This is the muffler box. There's a little bit of a maze of muffling material here because what we're in here, this is like a courtyard. It's actually overexposed. Sorry about that. It is a very, very sound reflective courtyard. I'm talking right now in my normal voice, and somebody on the other side of the courtyard can probably hear me perfectly intelligibly. So this is really easy to hear even faint noises. So this muffler box was an absolute necessity. So before I forget, this is the actual water tap. It goes over the ceiling. Obviously not able to see that right now. And this is extended from another bit of work that I did before to provide our air humidifier here with water. Yeah, this hackerspace is full of interesting projects. Anyway, the other hose you can see here going over the door and then down here, that is the exhaust. And it goes all the way down and down and down and outside into that cast iron sewer top. That's where it goes. So yeah, this is the fume hood I built and took me like half a year to do. I'm really happy with the result, but of course this is only a means to an end. I will be doing all kinds of cool chemistry in here. My end goal, probably not this year, but maybe, is to make a complete lithium-ion battery from scratch using this, and unfortunately you also need like a furnace for that. I'm also working on that. But of course other things that are cool to do and that I can do much sooner is gold extraction from electronics. Like, I mean, it's probably the most obvious chemistry thing that you can do as somebody who does power electronics most of the time. And yeah, all kinds of other things. I have a list of projects, and if you can think of stuff that you would like to see on this channel, then by all means, tell me. So I hope you like this video, and the next video about chemistry will probably be like a simple project, just something to get the hang of it and to show how the fume hood works and to show how chemistry on this channel will look. So yeah, hope to see you then. Bye.